Hello, and welcome to another episode of Introduction to Programming, C++, with your host, the Coder Hero, saving the world one line at a time. I have a new video format with pre-written code, so I can give you more audio commentary during this episode. In the last episode, we went over the installation of code blocks and the configuration of our compiler. Now I want to jump into programming and start displaying to the screen. To do this, we have to go over outputs. So let's begin. We have already preloaded our Hello World program from the last episode, and we've removed the output statement. Let's go over the base code on the screen. Up at the top, we have the include statement, which includes a library into our program. Next, we specify the library we want. In this case, the IOStream library, which stands for Input Output Stream. The next line contains the instructions to use the standard objects from the library. Using this command, we can access every object in the IOStream library without having to specify the objects in our code. In larger programs, you pay a performance cost though, as it loads every object out of the IOStream library. In order to limit the drain on our resources, we can specify which objects we want to use directly in our code. To do this, we use the standard prefix and 2 colons followed by the object we want to use. Here we are using the cout object from the IOStream library, so we type std, 2 colons, and the cout object. Since the applications and programming code we are going to be coding in these tutorials are small, we can use the namespace standard to help keep our code clean. Just note that in production environments, it is preferred to use the standard prefix before object calls to limit the amount of objects loaded into your program. Now that we've added the namespace standard, we can simply type cout and the hello world text again. Let's run our program to make sure that everything is functioning normally. There it is. Hello world. Note the space underneath thanks to our endline object call. If we remove the endline statement from our code and run it again, you'll notice that the extra space is missing. As the program processes output, the cursor position moves on the screen. The endline object command moves the cursor to the next line. Nice. Let's start displaying some other objects to our screen. We can start with numbers. Numbers, like say 42, can be displayed directly to the screen simply by typing in the number. No quotation marks needed. There it is, 42. Perfect. This works with real numbers as well. Let's display pi to the screen using the same cout statement. Oh no, something went wrong. We have pi displayed on the screen, but there's no space between our numbers. Just like text, numbers need endline commands to put them on separate lines. So, we'll go ahead and insert 2 endline objects after our numbers. Now when we print out our code, they should be nice and organized. There we go. Much better. Notice how all the decimal places are displayed? What if we don't want to display all the decimal places of pi? C++ allows us to set the formatting of our numbers using the setFlags function written as setF. To set the flags, we call it on our cout object with the dot notation. We type cout.setF and put some parentheses. Inside of our parentheses, we specify the flags we want to use by typing input output stream, 2 colons, and the flag we want. In this case, we're using the fixed flag, which means we don't want to use scientific notation. If you don't understand a lot of these terms, don't feel overwhelmed. We'll go over a lot of them in future episodes. Also, because we're working with real numbers, we probably want to see decimal places whenever we put a period. We can do this with the show point flag, which means when I put a decimal point, I want to see decimal places. Now, when we type, for example, 99 and a period, the display will show us decimal places after our numbers. Nice. How do we specify how many decimal places we want to see? I don't want 5 or 6 decimal places. Well, we can do this by calling a function on our cout object called precision. This sets how precise we want our decimal places. In this case, we'll set precision to 2. Now, if we type the same cout statement and run our code, you'll see that there are 2 decimal places after 99. Nice. Just the way we like it. Let's talk about the endline object and the newline command. When dealing with text, we can indicate that we want the cursor to move to the next line in 2 separate ways. We're already familiar with using the endline object command. We use the insertion operator and type endline, like so. The other way is to indicate a new line directly in our text. We do this by putting \n, like so. The coder hero \n, semicolon. Nice. The backslash within quotation marks is called an escape character. When the program encounters the backslash, it looks for the following text to get commands. In this case, n produces a new line. It works the same way as the endline object. Let's go ahead and run our code so that we can see that it works just in the same way. There we go. The coder hero on a new line, the coder hero on a new line, and a space underneath. We can use these either way on text. However, with numbers, we do have to use the endline object or type in a second text to put \n. What if we want to align our text on the screen? Let's talk a little bit about text alignment using another special character. Say we want to align our text towards the right of the screen. We can use a tab command by typing \t. Here again, the backslash is the escape clause and the T indicates a tab. We have to ensure that our escape clauses appear within the quotation marks. We can use as many escape clauses within a text as we want. In this case, we'll put 1, 2, and lastly, we'll put 3, just for fun. 1, 2, 3, and 3, and a new line. When we run our function, or when we run our program, you'll notice how on each line the text has been moved to the right to align perfectly with the amount of tabs that we've put in. 1, 2 tabs, and 3 tabs. Is there a reverse tab for aligning my text to the left? Unfortunately not. In order to align the text with the left side of the screen, we have to use a setWidth function. We can call this by typing setW and adding the amount of spaces we want inside as a parameter. In this case, we're going to set it to 5. And we'll give it a number like 99. When we run our program, oh no! Something went wrong. What happened? In code block, errors are shown with a red box by the line of code that failed to compile. The problem here is that setWidth is not part of the IOStream library. The library that contains the setWidth function is the IOManip library. So let's include IOManip. IOManip stands for Input-Output Manipulation. Now, if we run our code on a number, it will line up the way we want. Go ahead, run the code. Nice. 99. Perfect. Notice that the text is aligned 5 spaces from the left. I tried moving the screen around so you could get a better view, although you probably already have a good view. The setWidth function is useful when displaying numbers such as money, or just regular text to space it out from all of the other text. Let's go ahead and display a few dollar amounts to the screen. We'll start with $99, and we'll set the width 9 spaces. Seems good. And $99. And we'll create an endline object at the end. Then we'll display a second amount, say $2,000. $sign. We also want to set this width to 9 spaces and $2,000. When these numbers are displayed to the screen, regardless of their size, they will be aligned 9 spaces from the last cursor position, which was the $sign. Nice and neat. Just the way I like it. Let me make a bit of space here so you can get a good look at this code. Nice code. There are more special characters besides new line and tab. All of them use the escape character of backslash. One of the characters you'll need to use in your text is the backslash. Since this is an escape character, we have to indicate that we want to print it out by adding a second backslash. Since backslashes are super useful in things like web addresses. This is the same with the other special characters such as double quotation marks and single quotation marks. Each one typically ends a statement, so we use the backslash to indicate we want them included in our text. There they are. Backslash, double quotation, single quotation. Sweet. We also have the new line character in there. Softly quiet. Dope. The arrows that we've been working with this whole time are called insertion operators. We can add insertion operators inside of our text whenever we want. The use of insertion operators doesn't interrupt our code. The whole text will be written on a single line. When we run the program, you'll see that this is all on one line. Oh no. We forgot we don't have any spaces between our text. One of the pitfalls with using multiple insertion operators is forgetting to add a space between text. You can add it either before the insertion operator, after, or in this example, we could put it both before and after in the center text. In this case, I'll just put it after each operator. Sometimes we have a long text that we want to display to the screen, but we don't want to have to read across the entire screen. We can break up our code with insertion operators. Simply type in some code, close it with quotation marks, hit enter to move to the next line, and start your line with an insertion operator. Once you're done, tell the program you're finished by typing a semicolon at the end. Coding with the Coder Hero is the best. Nice. The semicolon is like an English period. Each line of code is like a sentence. You use the semicolon to indicate that the line of code is ended. When we run this program, what you'll notice is that though we have our code on separate lines, it will all get printed out on one single line. Perfect. Coding with the Coder Hero is the best. Totally is. You might have noticed that throughout this episode, I've been typing these double backslashes and typing brown code. These are called comments. The comments in a program don't get read by the compiler and help to make your code readable. Imagine coming back to over 1,000 lines of code from a year ago with no comments. It would be very difficult to understand exactly what your code was supposed to be doing. These lines don't get read by the computer. Comments help to specify what is going on in your code and make it understandable to other programs when they read your code. A double backslash creates a single line comment. There is another way to write comments called block comments. You indicate a block comment by typing a backslash and a star. Now you can write as many comments as you want. Once you are done, you can close the comments with a star and a backslash. Hey, don't touch this section of the program. This is main, and it runs everything. Okay, you can make slight changes. Star, backslash. You can also create a block around your comment by adding additional stars. In this case, I don't want any programmers messing with my code. Just kidding. I like to format my block comments just like this. Just like this. Nope, that was me saying just like this twice. Sweet. Nice block comment. And I like that it's in bright red, so it really stands out. That concludes this episode. If you would like a copy of this code, I will include a link to my GitHub repository right below. In our next episode, we'll go over getting input from the user and introduce variables. Thanks for joining me. Please like this video and subscribe to my channel to get updates on future videos. Now, get out there and code.